since it was designed for this intelligent industrial control devices, so it has a lot of overheads, and it has a lot of productivity as well. It provides good security, it provides good availability, and it has quickly spread to the SCADA environment, and like it has become most used standard for the most used protocol for the OT communication. It can connect up to like 254 devices together in a certain industrial control network. It is widely used by distributed control systems, DCS, and the SCADAs that they use to interact between RTUs and DCS. Like I said before, RTUs are talking to DCS, and the DCS are now connected with SCADA main servers. So the Modbus is the main protocol where RTU is talking to DCS, and now that DCS is talking to SCADA. Because if there is a conversion in between, availability will be impacted. So Modbus has become a de facto standard where from the RTUs, sensors to RTUs, RTUs to DCS, DCS to SCADA, there is a single protocol. So there is any conversion required, which provides a great advent in the availability aspect. DNP, Distributed Network Protocol 3, DNP3, is basically public industrial communication protocol. It was also developed for SCADA master servers. Mostly its implementation is between SCADA masters, the servers where SCADA is installed, SCADA servers we call, and interaction with the
Welcome to Global Information Security Society for Professionals of Pakistan.
Level 0 is also here, where we used to talk about all the physical protection of these devices. Level 1, level 2, level 3, and level 4. Level 4 is the place where IT is. Level 3 is the place where IT, OT are talking to each other. Level 2 is like entire OT, and level 1 are like PLC area where normal PLCs and all these things are working. You see these words EtherCAT and ProfitNet and Modbus, Profibus. So we'll talk about these words. These are like network communication protocols of industrial safety and protection system, like normal industrial systems before the involvement of IT to that. They have like safety systems as well. Any process can create an hazard. So to stop that process, you have like safety instrument systems, which is called as SIS. No PLC works without SIS. So if you have to compromise the process, you first need to take down this safety instrument systems as well. Because if you will do something and you have not taken care of its effect from SIS, safety instrument system. So say safety instrument system will protect any anything that should not happen. So to defend that, they have SIS equipment. They have certain levels. They monitor the values coming out from sensors. And now all this is being done through SCADA system. So you define certain SIL level of certain component. Like there is a sensor. In my last session, I gave an example for data center. So in data center, you have racks. In racks have certain temperature values. So if certain temperature value goes from, they have certain preset value, set point that I've talked about before. The set point you set is okay, 18 degrees centigrade, temperature should not go above it. So it goes like, okay, it goes from 18 to 20, there's a variable. So as it goes to 18 to 20, you will send an instruction to your AC to provide more cooling to that particular unit, because, due to certain server load, server are generating more heat. So, they're working on SIL1, but now temperature has exceeded to certain level called as SIL2, because the temperature is increasing, but AC is not providing that much cooling because a lot of servers has increased their temperature. So now, the maintenance guy will come around and they will see, okay, what's happening, why AC is not providing that much cooling. They have to turn on another backup AC, so temperature can be managed. So they will override the process and they will turn on that second backup AC. So temperature can be controlled, but the temperature is still exceeding and that it's not working. So now you have to shut down few racks that have low criticality. Okay, those are the racks that if their servers are down, there isn't any impact on main process. So you will inform the business decision makers, okay, this is something happening, and we have to engage a process shutdown process. We are shutting down these processes. They have preset instructions built. If you have like proper incident management planning there, so you can have, which is called as this HAZOP study. So it is called as HAZOP study. It is called a hazard and operability study. It is an analysis which is called as process hazard analysis. Process hazard analysis create this study which is called as hazard and operability study. Already you know what threshold will go, and you will shut what racks you need to do what. It's already mentioned in this study. So all the safety instrument functions will be defined in this study. Okay, if this thing happens, enable this thing. Like SIF will say you have to shut down any unit, you have to shut down the entire process. If this is emergency depressurization shutdown, it is related to EDPs. They are mostly connected with power sector or the water sector areas. Like if there is a plant who is creating electricity from boilers or steam or from a dam, so they need to shut down those as well. Like there's a flood situation, and to make sure that your electrical appliances or your electrical power generation system don't get compromised with the advent of so much flow of water. So there will be like flow of water will increase. It will be like it can destroy the belt of the belt of motor who's running from that water pressure. So everything has been studied that okay, this plates of this motor in a particular dam can resist that much pressure. So if that pressure increases, we have to shut down the entire power generation process. So now that water will not pass through that motors. It will directly go out from the system. So this industrial safety and protection systems, they help us to make sure that any hazard can be dealt before it results into something, a catastrophe. So now this was a short summary of what we have learned in our last sessions. Going further, we will talk about network transmission media. What are the network transmission media that are used by OT environment? Like normal communication media, we also have like copper wires, light waves like fiber optics, and wireless radio frequency RF, be it WiMAX, Wi-Fi, Bluetooth, Zigbee, and Z-Wave. Mostly this smart meter OT's environment, they work on this Zigbee signals. We have like same concepts of bandwidth and attenuation, and we have industrial network media standards that we will explore further. So the normal cables that we use in our modern day networking are also part of OT environment as well. But as I said before in my last session as well, that in OT, we have to look for the availability aspect. In normal IT, we have confidentiality, integrity, and availability, CIA. But in this OT environment, we have reverse, like it's availability first, then integrity, and then confidentiality. So here, was the sensor who are receiving that data, they have to perform at that very moment, and your entire process belt is running with certain sync. So if one process lags behind because of certain cable issues or challenges related to bandwidth or automation, definitely the other process will mess it up, and your entire supply chain can be either locked, or it can create delays in your manufacturing process, and your orders can suffer, or your entire manufacturing concern can suffer, or some god forbid bad thing can happen. So these digital data, they also travel from one network device to another network device, or from one particular OT sensor or OT machine to another OT sensor or machine. They also take these mediums. So, like I said, they normally use the same cabling standard that we will discuss further. Bandwidth and automation have an impact because availability should be dealt first. We cannot create availability issues when it comes to OT environment. So, industrial network media, like I said before, is RS-232. It is an asynchronous serial communication standard. Historically, industrial data communications, they were limited to like, okay, point-to-point transmission that has been directed between these cables. So these cables were used to create a point-to-point connection, RS-232. But then, the complexity of devices have become normal. Industries have moved from industry 2.0 to 3.0, now to 4 is the standard, and now we are seeing advent of AI with industrial standard 5. But initially, this RS-232 was the industrial network device connectivity standard for communication, that it used to provide up to 100 feet in length, like normal LAN cable, they have the same thing, 100 feet, it is also having the same length. This connection was first adopted to communicate between several other industrial IT devices and OT devices. The physical link that was used for 232 protocol has a specific cable, multiple cable like coaxial cable, and a specific hardware connectors. Now there was separate send, which is called as TX, and receive called as RX lines. In my last presentation, I have missed that topic in the refresher. There was like data diodes. So data diodes has whenever IT used to connect with OT, we have like data diodes in between. So these data diodes, they take data from IT to OT from one channel, and they bring the data from OT to IT from another channel. So they are called as TX and RX. And the technical word is used as TX and RX. TX to sending the data and RX to receive the data. So this RS-232, they have like separate send and receive lines that used to send control signals and receive control signals. Receive to send is a signal, clear to send, there are certain, if you talk about like TCP, TCP IP handshake. So there is also a handshake between these transmission control devices. So request to send, they take a request to send, diode will say, okay, send the data. It will say, okay, you are clear to send. So they can send the data. So they will say that, okay, I am ready, send me the data. Okay, I am ready to receive the data. So these data diodes, they used to work in that manner, and RS-232 was the communication standard between them. As you can see, the physical pin, it has like 9-pin D shell connector, male, female, both. So RS-232 devices were for the initial days, they were used to connect with the PLC from the computers through a USB port, so you can access them and you can do, like I said, engineering computers, the engineering workstation. They need to update certain OT device, so they will, they need to push certain information to them. So they use this cable for that. Then, you know, challenges started to come up with this communication. They were like, more data needs to be sent to the PLC. The flow of data from at the workstations were a lot that they have to transfer to, these PLC devices. Then RS 422, called as EIA 422, it was introduced for the same asynchronous serial communication. The main challenge why RS-232 devices were discontinued was the lag. They were creating a lot of lag, because now due to the data that is coming from behind, they require a lot of synchronization with that. And there was also a lot of automation issues. There were like a lot of noise was coming in those things in the cablings. So they replaced it with RS 422 protocol. Make use of it. It used to make use of that two pair twisted pair conductor, one for transmit and one pair for receive, to get it connected with the diodes. They have like a differential amplifier. It was kind of a driver for each a driver for each pair of lines. And they have a built-in feature which is called as noise rejection across a physical link. So any EMI, electronic magnetic interfaces, because when you talk about OT environment, and if like motors are running in that OT environment, or certain devices running OT environment, which is creating electromagnetic interferences, like which is called as EMI. So if any electromagnetic interferences are there in a network, so definitely the cable that are taking that data will have to receive a lot of noise. And because of the noise, once again, the availability aspect will be hampered. So to make sure that availability of data transfer is not affected, you need to reduce the electromagnetic interference from these devices, and the cable and the protocols, they become like important in dealing with that. After that, RS-422 came for a very short time, and there were like a lot of issues with that as well. Because as an RS-422 master transmitter device, it can host up to only 10 slave devices on a single media channel. So there were like issues of capacity in terms of supporting any the OT devices on the network. So that was replaced with 485, RS-485, which is as of now is a recognized standard for the connectivity on the cabling side. With the rise and expansion of IT networking technologies, I'm saying it again, that we have to make sure that the OT networks have the same throughput of receiving a data sent by the IT environment data. Otherwise, there will be lags. There will be like loss of data. Any single packet is lost, or any single piece of information is lost. They have to send it again. And once again, availability in OT environment, we can never compromise it. So, then it came like Ethernet connectivity. Now, Ethernet connectivity, as we speak, is the most common connectivity on the LANs providers. So, RS-485 was fastly replaced with this Ethernet network that become the part of OT environment. In my last presentation, if you go and see that, I've shown a box in which a PLC box in which there was a Ethernet connectivity option. So that Ethernet connectivity option was there, where you can use Ethernet technology and Ethernet cables to connect the entire OT environment with each other, with the workstation, with the SCADA system, with the data historians, and with the IT enterprise environment. But the problem OT environments have with the Ethernet technology is that data delivery times was varying. It was not deterministic. You cannot determine there be any lag, or will there will be no lag in it, just because of how this Ethernet works. Because Ethernet definitely has a lot of automation issues. It don't have any bandwidth issue, but it has a lot of automation issues. This Ethernet technology also have like data collisions as well. So network nodes, they normally listen to network media to find any opening. When they can transmit data, they cannot transmit the data, how this networking works. So once again, availability, it cannot be overlooked with this transmission media technologies as well. So to make sure that industrial network worked with the best technologies, the best form of cables needs to be utilized. Now, industrial network protocols, there's an association which is called as Open DeviceNet Vendors Association. They have they are the responsible body for making common industrial protocols, which is called as CIPs. The listed one are like Ethernet, IP. Here, IP does not mean Internet Protocol. It is industrial protocol. So Ethernet IP, this IP is industrial protocol, not Internet Protocol. It has two modes, one for scanner devices and one for adapter devices. Scanner devices, adapter devices are, the difference, there's a difference between scanner devices and adapter device that we will see. And we'll talk about all these protocols: Modbus, Profinet, Profibus, BNP3, ICCP, OPC, and BACnet. As I have highlighted in red, that the two protocols that are 60% of the market are Ethernet IP and Profinet. These are like most commonly used protocols in OT environment. So the Open DeviceNet Vendors Association, they created this common industrial protocol standard for their members to use in developing industrial network protocols. So CIP is media independent, object-oriented protocol that spans a suite of services for this entire OT networks. Like you are seeing that from top to bottom, there are a lot of protocols, and each one of them has their proper utilization, which I said, we might be using a mix of them. We might be using only Modbus on our entire segment. We might be using BACnet for certain processes. Everyone has its cons and pros, and definitely we cannot cover this in this presentation. So if we need to look on that, you can Google them, you can browse them, and you might learn a lot about them. So these common industrial protocols, they have certain variation. The reason that they are very have certain reasons, like configuration. Every protocol has certain configuration overheads, synchronization issues. Some of them have like safety issues. Safety, I mean, they can be compromised by certain types of attacks. So, protocols are subjected to attacks. So if a protocol has a very less secure or integrity thing, they can be compromised. So depending upon, it's a closed loop process, closed loop control process that I've said, that it is not interacting with any third party or any other process. It's a closed loop process, working on its own only. So you can use BACnet as well. BACnet is basically a very light protocol, but has a lot of security issues. So you can use that, but you will not use Ethernet IP over there because it has like huge configuration is required. And whenever you increases the configurations, definitely payloads increases, and you need a higher bandwidth and less automation issues over that cable. So talking about this Ethernet IP protocol, it's basically in like name says, it's basically an Ethernet based technology where it is required for the where you need to converge from IT environment to OT environment. So it can work on both ways, right? You can use it inside OT to OT communication, and most prominently its utilization is from IT to OT. The gate of any bad malicious actor to get inside any OT environment is the IT OT convergence. So this Ethernet IP industrial protocol, it provides a lot of security configuration, a lot of configuration that makes this reliable for the security implementation. So one of the keys to this OT-IT network integration process, like I said before as well, is the development of protocols that combine traditional OT functions with IT networks. Like just as an IT network has expanded, like TCP/IP protocols, there are a lot of protocols who are carrying like audio, voices, and the payload that has to target OT environment will come in between them. So when there is where there is a convergence from OT to IT, so now the ICS industry has to see that what are the ways and means that this bad actor can transfer from IT to an OT environment. This Ethernet IP protocol was originally developed by Rockwell Automation. They are like the most prominent OEM in producing network communication technologies. So they have produced this protocol as well. It started in 1990 and mostly become the part of Industrial 2.0 at that time. It was like industrial revolution at that time. So the scanner device and adapter device that I said, scanner devices are the one that are open, or that they open connection and initiate the transfer. With the adapter, you need to supply them certain kind of a data to authorize yourself, and then they will take the data. So the scanner devices, adapter devices are the same. Scanner, they just open up. It's like a UDP connection, TCP/IP. The difference is with the scanner devices and the adapter devices. So in like IT environment, there are applications exchanging information, but in OT environments, there are also protocols between certain network devices, certain OT devices as well. So one OT device, needs to talk to another OT device, but that OT device is talking into another, and is talking in another protocol. So you need to bring in a controller which is called as CNC, computer numerical control, which translates the protocol in one form to another form. Modbus, it has become the de facto communication standard for all intelligent industrial control devices. Modbus, it's basically a serial communication protocol that was developed specifically to provide networking capabilities for industrial control application. Since it was designed for this intelligent industrial control devices, so it has a lot of overheads, and it has a lot of productivity as well. It provides good security, it provides good availability, and it has quickly spread to the SCADA environment, and like it has become most used standard for the most used protocol for the OT communication. it can connect up to like 254 devices together in a certain industrial control network. It is widely used by distributed control systems, DCS and the SCADAs, that they use to interact between RTUs and DCS. Like I said before, RTUs are talking to DCS, and the DCS are now connected with SCADA main servers. So the Modbus is the main protocol where RTU is talking to DCS, and now that DCS is talking to SCADA. Because if there is a conversion in between, availability will be impacted. So Modbus has become a de facto standard where from the RTUs, sensors to RTUs, RTUs to DCS, DCS to SCADA, there is a single protocol. So there is any conversion required, which provides a great advent in the availability aspect. DNP, Distributed Network Protocol 3, DNP3, is basically public industrial communication protocol. It was also developed for SCADA master servers. Mostly its implementation is between SCADA masters, the servers where SCADA is installed, SCADA servers we call, and interaction with the PLCs or the IDs in electrical grid systems environment. Mostly because it has its roots with the there is a NERP, there is a authority in US who is working on this power grid OT security. They are kind of a regulator there, so they prefer this DNP3 standard, where SCADA master servers needs to talk with the IDs. So DNP3's mostly utilization is, okay, you are sitting inside SCADA system, you are sitting on SCADA screens, and you need to talk to any PLC there only. It will not be used to like Modbus. Modbus was used from SCADA to RTUs, where remote telemetry unit, they are sitting somewhere in another part of the world and they are sending something on Modbus. But here, since any, like I said, the data is coming from RTU to DCS, and DCS to SCADA, and SCADA to PLC. So now SCADA and PLC, they are preferably talking in DNP3 standard because it is being referred by NERP, the American National Grid Regulator of power sector. And if they are a part of power sector, so SCADA will be talking to the PLCs of electric system grids in this protocol DNP3. ICCP, Inter-Control Center Communications Protocol. Mostly the difference between in all these protocols is the industry that is utilizing them. Because certain, the SCADA working, SCADA is a system which is common for all kind of a process automations, like, power sector, water sector, manufacturing concerns, you name it, SCADA is there. But the devices on the receiving end, like for energy sector, the OTs will be different than OTs that are in aviation, then the OTs that are different in water system. Like I talk about the dam system, right? So they have different OTs than the electric system. So the usage of all these protocols depend on what kind of industry you are addressing from the SCADA. Now SCADA needs to talk to these equipments. Now those equipment have certain pre-built fabricated protocol that they will send the information on the field bus. You remember that field bus, the main road where all SCADA devices were connected. So all devices, they are sending, like I have a device that is NERP compliant, NERP compliant, and has only that DNP3 to understand. So now I will configure my SCADA system to understand that protocol. Now that SCADA is collecting certain information from DCS through Modbus. So I will, and as a SCADA, I will understand both Modbus information, convert it into something SCADA can understand, and then will convert it into DNP3 language. So it will be sent to that particular electrical grade OT device. Like this BACnet is basically Building Automation and Control Network Protocol. Building Automation and Control Network Protocol developed by American Society of Heating, Refrigerating and Air Conditioning Engineers. So now here there are OT devices, right, who have a particular relation with HVAC, heating, ventilation, ACs, where all the data center and all like modern buildings, this is like HVAC system, which used to monitor the heating and AC air conditioning controls in the entire implement. It's all OT as well. You know, you might have like a centralized AC system in your building. So you just go there and plug certain value of room temperature. So now that room temperature has to be managed. That particular small device where you are managing that room temperature is an OT, right? And so it is now asking that centralized system of building to send certain piece of heat or cool into your room. So, there's certain protocols that are there are certain devices talking to each other in certain protocols. Protocol is basically the language, the signs that one guy can send to another and another can send to me, and we both need to understand each other. So this all the automations related to heating and refrigerating like HVAC controls is followed by BACnet.